Hello, this is Miss Moore, and today during chemistry, we're going to continue our discussion on stoichiometry. Specifically, we're going to talk about mole-mass conversions. Today's essential question: given the number of moles of reactant used, how do you calculate the mass of the products? Today, you should have both your calculator and your periodic tables handy. Okay, let's do this. We'll start with a really quick review on determining molar mass. And remember that molar mass is the mass of 1 mole, or 6.022 times 10 to the 23rd atoms or molecules. Okay. And you get the mass from the periodic table. It's the atomic mass in the units grams. All right. So let's start by making a list of the types and amounts of each atom that we have in our compound. So sodium, we have 2. Sulfur, we have 1, and we also have oxygen, and we have 4 of those. And we're going to multiply the amount by the molar mass, which we get off the periodic table. So for sodium, right here, the mass is 22.99 grams. Sulfur, we have 32.07 grams. And oxygen is here. We have 16 grams. All right. So let's figure out each of those. So for sodium, we have a total of 45.98 grams. Sulfur, we have 32.07 grams. And oxygen, we have 64.00 grams. Now, my calculator actually came up saying just 64, but I know it looks like we're multiplying, but we're really adding 16 plus 16 plus 16 plus 16. And when you're adding with sig figs, you look at the digits after the decimal, so we need to add those too. All right, so when we add those all up, we end up with a molar mass for sodium sulfate of 142.05 grams. So hopefully you remember how to do that, but just wanted to make sure. All right, let's learn how to do mole mass conversion. So the first thing is we've got to go over some equalities. Hopefully all 3 of these equalities will be somewhat familiar to you as we go through this. So the first one is molar mass of the known equals 1 mole of the known. Okay, this one we've used before. If you remember when we did mole conversions, we had 1 mole of blank equals molar mass in grams of blank. This is the exact same thing. The only difference is instead of blank, I'm telling you specifically you've got to use the molar mass of the known. Okay? And where do we find the molar mass? This is found on the periodic table. It's what we just calculated a moment ago. Okay, the next one is, a blank mole of the known equals blank mole of the unknown. And this information comes from It's the coefficients from the balanced equation. Okay, we used this one when we did mole-mole conversions. And then the last one is very similar to the first one, which is 1 mole unknown equals the molar mass of unknown. And the only difference is we are now looking for the mole or the molar and the molar mass of the unknown. By the way, you can find all three of these on your unit conversion table. So if you find your orbital diagram handout flip to the back, you should see these on the right-hand side towards the bottom. So you might want to get that out and check that out so that you know where to find it. Okay, let's learn how to solve a problem here. So our practice problem is calculate the number of grams of NH3 produced from 4 mole of H2. All right, this is very similar to our mole conversions. Our first step is going to be to identify the known and the unknown. So my known would be right here, 4 mole of H2 is my known. And my unknown, or the thing I'm looking for, is grams or mass of NH3. Now, just like before, we write our grid and fill out our known over 1. So we have 4 mole of H2 over 1. All right. Next step is to find an equality. So what we look at is that we're starting with mole known. Okay, mole known. So let's go back to our list of equalities, and which one starts with mole known? The second one. This one right here starts out with mole known. That's the one we're going to use. So, and remember, we just use the coefficients from the balanced equation. So if we look at our balanced equation, our known is the H2. And while we're here, let's identify our unknown as well, which is NH3. So that is what we're going to use. We're going to end up with 3 mole H2 equals 2 mole NH3. Basically saying that when you use 3 moles of H2, you make 2 moles of NH3. Now we need to put this into our grid, setting it up so our units cancel out. The problem is they're both mole. So instead of looking at the units, we're going to look at our molecules. We have mole H2 up here, so we need mole H2 at the bottom, which means the other guy goes here. Let's get rid of this extra stuff. Now let's cross out our units and check where we're at. So we're at mole H. We've crossed out mole H2, mole H2. We're at mole NH3, which is our unknown. However, we were looking for grams of NH3. So we are not done with our problem yet. So we're now at mole unknown. So let's look at our list and see what has mole unknown in it. The third one, 1 mole of unknown equals the molar mass of unknown. So our unknown was NH3, so we're going to say 1 mole of NH3 equals the molar mass of NH3, which means we're going to add up the mass of 1 nitrogen and 3 hydrogens. So let's find those on our periodic table. Nitrogen, molar mass is 14.01. Hydrogen, molar mass is 1.01, but we need 3 of these, which makes it 3.03, plus our 14.01, which gives us 17.02. grams of NH3. All right, now we have to set these up so that our units and compounds cancel out. Since we have mole NH3 up here at the top, we need that at the bottom. So they'll cancel out, which means the other one goes at the top. All right, let's cross out. We have mole NH3 crossing out mole NH3. We are left at grams NH3, which is what we were looking for. So now we are done setting up our problem, and we just need to multiply across the top, multiply across the bottom, and then divide. So when I multiply across the top, and please be double checking me, I got, let's see, 136.32. Ooh, I'm going to run out of room here, so let's move this. Let's try that again. I got 136.32 grams of NH3 over, multiplying across the bottom, 3. When we divide, I came up with 45.44 grams NH3. All right, last step is sig figs. And so for sig figs, what you're going to be looking at is, let me scroll up a little bit. You're going to be looking at your given and anything calculated. Oh, by the way, this is for sig figs. And so what we calculated was the molar mass. Okay, so let's see. Our given, let's see, we had 4 moles. So that's 1 sig fig, right? I'll put it here. 1 sig fig. These here were not calculated, nor were they given, so we don't use those for sig figs. This was calculated. We have 4, so our final answer needs to have 1 sig fig. So let me change colors. I'm writing all over this place. So here was our answer. We want to keep just the 4. So we look at the first number we're going to drop, which is the 5. 5 is 5 or bigger, which is rounds the 4 up to 5. 5 is not a good rounding of 45. Remember, whenever you drop a decimal before a digit, try that again. Whenever you drop a digit before a decimal, you need to add a placeholder. So our final answer is 50 grams NH3. Okay, so this really, hopefully, you don't see this as too difficult. It's very much like mole conversions, just you got to think a little bit more. All right, let's try another problem. All right, here we go. If 625 grams of Fe3O4 is produced in the reaction, how many moles of hydrogen are produced at the same time? So the first thing we should do is identify our known and our unknown. So our known would be 625 grams of Fe3O4. I'm going to go ahead and identify that in my balanced equation as well, because I know I'm going to need it. And my unknown is moles of hydrogen, because that's what it's asking me a question about. And I'll identify this too. All right, so from there, same old thing. Let's write our grid and put our known in the grid, which is 625 grams of Fe3O4 over 1. Next is to find an equality. So we're at grams Fe3O4, which is our known. So let's go to our list. Well, we have mass of known equals 1 mole known. So we're going to use that one. So molar mass we get off the periodic table, and we're looking for 3 Fe's and 4 O's. So our Fe is right here, and the molar mass is 55.85 grams of those, and we have 3 of those, and oxygen, we have 4. All right, when we add those all up, if I did this correctly, I got 231.55 grams of Fe3O4 equals 1 mole. Fe3O4. And you could have written it the other way around. 1 mole of Fe3O4 equals the 231.55. Doesn't really matter. All right. So now we got to figure out which goes on top and which goes on bottom. Well, we're at grams, Fe3O4, and that would be this area here. So that part will go on the bottom, and the top will go 1 mole. All right, so now let's cross out our units. Grams Fe3O4 indeed crosses out grams Fe3O4. And we are now at mole Fe3O4, or our mole known. We were looking for moles of hydrogen, or mole unknown, which means we are not done with our problem yet. Okay, so we're at mole known, right? Fe3O4s are known, and we want to get to mole unknown. So let's check that out. Here we go. Mole known equals mole unknown. We use the coefficients from the balanced equation. All right, let's do that. So our known is Fe3O4, and the coefficient is nothing, right? Which means there's 1 of them. So 1 mole Fe3O4 equals, our unknown is H2, 4 mole H2. And we need to stick these in our grid. And we're at mole Fe3O4, or our mole known. So that one's going to go on the bottom. And this one's going to go at the top. And we cross out our units. And we're left at mole H2, which is indeed what we were looking for, which means we are now done setting up the problem, and all we need to do is multiply and divide and stuff. So when I multiply across the top, I ended up with 2500 mole H2. Multiplying across the bottom, I get 231.55. All right, when we divide, I got 10.7968, etc., mole H2. And the last step is sig figs. Remember, we use our given and any calculated numbers. So our given is this, which is 3 sig figs. We have calculated that, which is 5 sig figs. And these were not calculated or are given, so we ignore those. So we're going to have 3 sig figs, which means we want to keep those 3. The 9 is the first number we're going to drop, which is 5 or bigger, which rounds our 7 up to an 8. So final answer is 10.8 mole of H2. All right, so that's how you do mole mass conversions. It's really no different than doing any other kind of mole conversion. You just need to really think about what is your known, what is your unknown. You need to really look at your equalities, write your units, write the molecule or atom, and just keep checking. Where are you at, where are you at, where are you at till you get done. All right, folks, that's it for today. Have a good one.